Good morning, everyone. It's Monday, February the 9th, and welcome to 7 Investing Live. This is our live stream show where we look at some of the most intriguing opportunities in the stock market and some actual opportunities to invest in individual companies. My name is Simon Erickson. I'm founder and CEO of 7 Investing. You can follow along with our live stream event every Monday, Wednesday, and Friday right here on our YouTube channel at 10 a.m. Eastern. You can also check out our own website, 7investing.com, to see all of our actual recommendations, our actual stock market recommendations each and every month, as well as our 5 best buys every month. And your first 7 days are completely free. That's over at 7investing.com. I am so excited to be joined this morning by Robert Quinn. He is a semiconductor ambassador. He's been all over the world advising companies, advising academic institutions, and actually putting his own hands to work on designing and installing equipment for fabs. There's a lot going on in the semiconductor world today. Robert, I am so excited to have you here on the show. Welcome to 7 Investing Live this morning.
Simon, I'm excited to be here. Thanks so much. I had some technical difficulties this morning, of course, getting cameras to work, but good to be here. Thanks so much.
You bet. I'm so glad to have you here too, Robert. And by the way, got live stream. That's part of the name of the game, right? It's just kind of roll with the punches on stuff like that. I want to pull up actually a post that you had, Robert, to kickstart this. I'm going to do a real quick screen share here, and we're going to show a post that you put up here on LinkedIn right here, which I thought was pretty interesting, talking about Elon Musk. The great disruptor of industries. Seems like he is very interested in the semiconductor industry these days.
Yes.
And you pointed out that he's got the plans of building a TeraFab for Tesla, something that might produce up to 200 billion semiconductor chips every year. To put that number into perspective, the world collectively spent about $800 billion last year on around 1 trillion chips. So if Elon were to actually manufacture his own chips for Tesla's internal demand or however he wants to use these, the TeraFab could be up to 20% of the global total semiconductor output. Robert, how do we unpack this? First of all, this is an ambitious project, but we know that Elon is an ambitious guy. Tell me just your thoughts about, is this even doable, being that we're so reliant on the world's largest manufacturers of semiconductors today?
We're doing amazing things right now. We're doing things that a lot of people don't even know about. I'm working with companies that are actually launching atomic layer deposition processing into space right now, to be completed by Q1. Like we're wanting to do a chip processing in space, and right now it's more of an R&D phase. Like, hey, what happens at zero atmosphere when we're doing atomic layer deposition, and how do the physics change, right? And so there's a lot of those kinds of questions, but we're also launching GPUs. He's definitely going to be launching data centers into space. There's no question about it. He's very ambitious about that as well. But yeah, the chip fab, I think eventually he tries it. I really do. I mean, he has a lot of naysayers. I get a lot of comments and a lot of there's a lot of hate out there for Elon, but
every day.
I believe if there's anybody in the world that can do it, it's Elon. Like, he just has proven himself time and time again. He thinks a little bit farther out, and he doesn't always hit his goals on time, but he's achieved quite a bit, and I would say that he understands. He does understand the challenges. I think he does understand those challenges, maybe not to the full nth degree of the physics and the processing and yield enhancement, but that'll be the challenges. Where I see him being really successful, though, is there's a lot of inefficiencies, I think, in the way that we manufacture chips today. For example, taking down a tool, and why isn't this done like a Formula One? Why aren't we having for a PM? Why aren't we having this as such a setup so it's like a Formula One race car, right? This machine is making money. We should be able to come in, pull one chamber out, pop another chamber in, and then take off again. If it's responsible for producing that much money, it should be run that efficiently. We're not running the fabs. I don't truly believe we're running fabs at the efficiency that they could be. So that's where I see Elon really coming in and changing a lot of things as far as efficiencies, making things super efficient within the tools. But he does come out with some crazy things like eating a cheeseburger and smoking a cigar, saying that he wants to eat a cheeseburger and smoke a cigar in the fab. Um, how are you going to be able to smoke a cigar and do a PM on a physical vapor deposition tool that is, responsible for doing things at 3 nanometers? Like you're going to contaminate the chamber. Unless you have a separation of that tool within a clean room space, whatever. I don't know what his thoughts are on that, but who knows where he wants to go and what he wants to do. But I truly believe he's going to get into this race. I really do believe he's going to try to get in this race. And right now, the big bottleneck is in memory. And he was just online yesterday talking about that. And the day before, he's been talking a lot about memory and how this is a huge bottleneck for the whole industry. And I think he's going to get into it as much as there was just an incredible amount of hate. Like, I mean, the information that came out, the comments that came out on that post, every time I comment on Elon, there's just an incredible amount of comments that people that dislike him and don't believe that he'll be able to do what he says he's going to do. But I think really, if anybody, I like to say that, I like to give him a benefit of a doubt, right? And if he can do it, if anybody could do it, it would be him. And let's see what happens if he can get into building a TeraFab. Wow, how incredible would that be? It would be a massive investment, but I think it would be something that could pay for itself.
Well, first and foremost, as someone who is the son of an operations manager of a refinery, I know how important downtime is and efficiency. I'm right there with you. There's a lot of similarities
Yeah.
between oil refineries and tooling of fabs. But I do want to talk a little bit more about how this would even look, because much better than I from the last 30 years of your career, Robert. We keep building larger and larger machines, and we've got Moore's law. That's kind of a limitation on the physical side of this. You've got ASML now producing $350 million EUV machines, extreme ultraviolet lithography. And then, of course, all the equipment makers, whether it's for the wafers, whether it's for the deposition, whatever it might be.
Yeah.
Is this going to follow the same rules we've gotten used to in constructing these fabs that are now up to $100 billion a piece? Or is Elon and whoever else might be manufacturing chips in the future going to play by a different set of rules?
I don't think there's a way around it.
Yeah.
You've got to spend the money. Yeah, you're probably going to start off with a minimum of a $40 billion facility, and then add on to it from there. But I don't think there's a way around spending that kind of money with these tools. Elon himself said, are you going to reinvent EUV? And he was like, I don't know about that one. That's that's a very advanced technology that even China themselves can't copy. So it's I think if he's going to get into the game, it's going to be a very expensive game to play. This is a very you call it cards. It's the expensive card table. It's the most expensive card table to be at, poker table to be at, because you can absolutely lose it all. If you're not building if you put all this money into building the facility, building the fab out and filling it with billions of dollars of tools, well, that's only part of the picture. You still have to get in there and perfect a recipe. Even Samsung is still trying to perfect their EUV recipe. Intel's still trying to perfect EUV recipes. TSMC has a pretty good handle on it. They're doing a really good job, but they have a long run ahead of they started this race a long time ago, and they're proving now that the reason why they're doing so well is because they invested early. And so where do we go with building? But if he builds it, it's going to be, he has to invest the money to get it done. So
It's going to be interesting to see the relationship with Taiwan Semiconductor, because so long we've relied on them, and it has political, implications on this as well, being located so many of their fabs in Taiwan. But they're spending, what is it, 30-40 billion dollars a year on their own capex budgets, plus they've got 40 years of IP and know-how on doing this. It's ambitious
Yeah,
to say, okay, we can just all of a sudden start from scratch. Money aside, it's still a very, very technical challenge. We've seen Russia
very.
try it, we've seen China try it. It just doesn't seem like it's something you can just pack up and do, even if you've got the capital available for it. But even the implications of this, Robert, would it be correct for me to assume that if Elon does do what Elon does, get an ambitious project that costs a lot of money, would this generally be good for the equipment suppliers like the ASMLs and the applied materials of the worlds, but bad for the manufacturers such as the Taiwan Semis or the Samsungs of the world? Would I be reading that correctly if you've got now another player that's manufacturing the chips?
Um, so one of the things that he just mentioned is that he would like to reinvent. He would like to kind of get into the business with the KLAs, applied materials, the LAMs, and then build these first fabs. And then over time, he would like to modify and the equipment that is being that he's bought from those companies, and increase efficiency and try to do other things with them. What's the legality to that? Can you go ahead and would he be able to build his own tools at the end? Is that copying IP? Is that uh, I don't know. I don't know the laws as far as that goes. I don't know if he can do that, but yeah, it's hopefully he'll be able to come in with the applied materials. First phase is to come in, build the fab, come in with the big expensive tools, fill the fab up. Put in manpower. You have to have the knowledge and the engineering and the experience, and he's got to hire. He's going to have to go in and hire the best of the best of the best from around the world to be able to build a facility like this. It'll be very challenging and very expensive to do, because it's not in this industry. It's not if you build it they will come. It's if you build it and then you perfect the recipes, and then you perfect the recipes, and then you perfect the recipes, and then finally you'll have a yield that's going to be efficient. That's going to produce a return on investment that your customer's going to want. But it's not something that is going to be easy business to be in. So.
I do want to talk about that in just a moment, about the building and then the perfecting the recipe and getting the yield to the optimal level. Here in a second, I want to talk about those. Before we do though, Robert, I do want to kind of talk about, you have such an experience in this industry, right? And I know that you've got a media company, Quinn Media, also that you're working with right now, but you're also kind of advising a lot of people that are building some pretty ambitious projects yourselves. Can you just tell me generally what you think of where we stand in the semiconductor industry today and how you've seen it innovate over the last couple of decades? Any kind of 10,000 or 20,000 foot level thoughts or comments or insights would be pretty appreciated right now.
Yeah, yeah. Well, I started in this industry in 1997 in applied materials, worked my way through, all manufacturing, and then to chamber test, and then final test, and then final test in many different platforms as far as PVD, CVD, LD, or TP EPI, and then went out in the field as a field engineer and traveled the world and worked at all the different fabs around the world as a field engineer, doing installs, deinstalls, troubleshooting for specific tool sets. It was an amazing career. Eventually, my wife said I had to come home, so
Yes.
I took a senior engineering job at Samsung for a few years, and then moved into couple small companies and operations because I was getting old, and wanted to. Tired of suiting up in bunny suits every day, and so I went into management for a little bit, and that was when I started writing on LinkedIn. And I said, well, I have 20 years of experience, and Gary V from YouTube. Gary V says, do something for others, ask for nothing in return, do it on a daily basis. Say, well, I'll take this challenge and see how it applies to what I'm doing. And so I just said, I'll just start writing on LinkedIn about what I'm reading about every day, and how the industry is changing and what's going on. My gosh, we've seen a lot of change over these years. It's I came in in 1997, and here we are in 2026 doing 3 nanometers at full scale. Like, it's unbelievable to see that change. One of the things I always like to explain I have a nonprofit organization where we're trying to get kids excited about semiconductors. And one of the things I always do is I tell them, I say, listen, these machines that we work on, they pump down to a vacuum that's 10 to the -9 torr. That's deep space vacuum. We're injecting a plasma as hot as the surface of the sun. We're exciting the molecules inside of these chambers. We're getting these, we're now building transistors at 3 nanometers. But I like to talk about the fact that we've gone from a single transistor. We followed Moore's law for 70 some odd years. A single transistor that was this big to a chip. Oh gosh, if I had it somewhere here, I did have it. But a chip that's 2.6, here we go. This is a
there it is,
2.6 trillion transistors and 850,000 cores.
That's huge. I mean, it's about to IPO this year, right? Yeah.
To wrap your head around that's incredible, right? Like, that's wow. We've really scaled. This industry has absolutely changed so much in the last 70 some odd years, where we've just scaled from a single transistor to these trillions of transistors on a chip. Unbelievable. And so it's amazing to think about where this technology goes in the next 30 plus years. The trajectory is just absolutely vertical. And it's no longer a scale of transistor density. It's a matter of computational power, and how little power we can use for computational power, to do that. And so now we're going to do 2D stacking and 3D stacking, and using architectures like neuromorphic computing, and using the architecture of the brain versus the old architecture that we used to use. And so, yeah, a lot of that changes. And how do we adapt to that? Well, we continue down this road of growth, and it's going to be a wild ride. I tell you what, because the 74 years has gone like this. The next 30 is absolutely vertical. Absolutely vertical. The growth trajectory is going to be absolutely amazing. It's such an incredible speed. So,
and you're right. It seems like there's a lot of creativity right now in the designs, right? Whether you're talking about the nanosheet architectures of the transistors themselves, or the 3D print, 3D stacking of chips on top of each other, chiplets. AMD always wants to talk about. Is there any technology right now that you think is really exciting for you, or something we should be paying a lot more attention to?
Everything has. You hear a lot about different architectures and different ways of doing things. And it's such a mass adoption. It's such a huge adoption for a standard to become, for something to become a standard internationally, and to be, well adopted and implemented. And nothing that, just really stands out to me as far as that goes. But, the changes we're going to see is just the demand for chips. The one thing I talk a lot about is supply chain. How are we going to sustainably build the chips that we need for the world? That's big problem. And we're not doing it. Memory is just destroying the market right now. Every company in the world is scrambling, figuring out what they're going to do with, how they're going to implement memory. The vacuum on your floor has memory built into it. Like, all these devices have memory in them, and so everybody's scrambling. Trying the robo vacuum, whatever it is. But yeah, so everybody's trying to figure out, what we're going to do about chip demand. You don't build these plants, these facilities overnight. It takes 3 years to build a memory factory, a fab. So yeah, and then the cyclical ups and downs of the demand is so hard to predict, whether or not we need the fabs, because the fabs have to stay at full capacity to be able to make money. So that's a challenge for them, right? But
well, there's always been the meme and the joke, that if you're on a desert island and you write help into the sand, no one's going to show up. But if you write DDR RAM, then all of a sudden ships are going to be flocking to you immediately. Certainly one of the bottlenecks.
Yeah. That was a good Elon. Yeah.
And Heather, if we could put a graphic up here, that kind of some research that we got from excuse me, Bank of America last year on, what is going into a data center today in 20, or at least in 2025. Because like you mentioned earlier, these are massive projects. $40 billion
Yeah,
probably at least is a table stakes to build a
yeah.
data center. And we always talk about Nvidia, and we always talk about AMD, and the chips are going to the servers, but it's a lot more than just that, right? Here's just some examples of some of the other infrastructure that's required for these massive projects out there. Other than memory, Robert, is there any part of the infrastructure right now, be it power, be it water, be it air conditioning? Is there anything that you see a real bottleneck or a shortage of supply that might be impacting how quickly new fabs can go up out there?
I've had the chance to attend a few data center events lately, and kind of really trying to dig into their infrastructure, and had some good talks with some executives in the data center industry. And it absolutely does have bottlenecks. At one of the biggest bottlenecks that they were talking about at the event I went to in Houston was right now it's transmission lines. We
Mm,
can't get the transmission lines to the facilities. We've built we're building the data center. We've got the chips. We've got everything ready to go. We don't have the power to turn the light switch on,
yeah.
and so that's a big problem. One of the things I've been working with lately is, and I was actually out at Texas A&M, seeing their new site where their new SMR, small nuclear reactor, is going to go.
Mm,
And so there's a lot of testing of SMRs, and we're going to. I believe this is the answer to the data center problem right now is moving into the small nuclear reactors and having them on site, and so they can produce that power for those facilities. And it's going to be expensive, but it's going to also be, they're going to be able to justify it over time, I think, with the cost of electricity, and not having to pull money from the grid to be able to, other people are complaining that data centers are raising the bills of other cities and other neighborhoods and whatnot. So this, SMRs would be just a great way to deal with that. But yeah, I mean, we're talking about, like, I was talking the other day about this Abilene data center. Is it Abilene, the one that's going up in Texas? The Stargate project, right? They said somebody said that thing is going to take 5 Hoover dams to run by the time it's all said and done. By the time it's all complete, years and years, 2030, something like that. They've maxed it out in the 80-acre site. That it's going to take 5 Hoover dams to power. Can you imagine? That's an incredible amount of power. And so power is obviously a big bottleneck. Getting the transmission lines to the facilities is a huge bottleneck. And then of course, having the massive capital to build these data
Yeah.
servers and move them in. That's one of the things. I actually work with a company that is purchasing, going in for the customers, and the customers are saying, "Hey, I've got all these servers, and I've got all these GPUs. I want you to come in." And so I work with a company that comes in. We purchase the GPUs, the servers, the chips. We move them into a free trade zone vault, and we store them in a free trade zone vault. And then we're able to. So they say, "Hey, I need 90 GPUs per quarter, or I need." And we're able to store them indefinitely for 20 years because JIT is truly dead, just in time delivery, because it's always just the next COVID, the next tsunami, the next Suez Canal. There's always something that's always stopping it, right? So that's clogging up the JIT system and making it not work. So this is truly a just in time delivery where we're coming in with our capital. We have $1 billion capital, be able to purchase materials, move them into a free trade zone, and then they're able to take that material as they need over 5, 10, 15, 20 years. And so that's one of the things I've been working with a lot, and working with data center companies and trying to help them with that, because there's been a lot of pushback lately. Companies are saying, we're going to be about 6 months behind schedule. And the guy's going, I've got $300 million of servers sitting here that I need to get off the books, and liquidity is gone. And so, yeah, it's a big problem for a lot of companies that we're able to solve. So,
And you've lived it, right? You've seen the lead times. I mean, for transformers being 18 months sometimes from these guys, the air conditioning units themselves being, it seems like just the supply for these these companies, the Trains of the world or the Vertivs of the world for liquid cooling, whatever it might be, Schneider Electric. I mean, they're doing the best they can, but at some point you can only produce so much, right?
Yeah, exactly.
The
And
power
we
one.
have to. The power is absolutely a tough one. Yeah.
Amazing. You think about it, Facebook now, Zuckerberg has mentioned out there that he wants to build a 5 gigawatt data center. That is insane because the power required for a 5 gigawatt data center is larger than the largest nuclear power plant in the United States today, which is in Georgia, by the way. So it's just like the power itself is going to be such a bottleneck. I think you're right that, maybe it's got to be a small modular reactor, a self-contained nuke that's not feeding the grid, it's feeding the data center now. So you're not just pushing the prices up for electricity for the rest of us.
Well, the research, the stuff that I've been looking at, and the goal for Elon, again, there's StarCloud, Elon, and a few other people that are talking about data centers in space. And so, I mean, solves a lot of problems.
Yeah.
Power issue. They've got, they can. They've got free power because the solar panels. I think they're 8 times more effective in space or something
No
like that.
clouds, no rain.
No clouds, no rain, and it's constantly pointing to the sun.
Yep.
So you have 24-hour power. There's a lot of solutions to doing it in space. And hey, who knows? Maybe we'll have the Optimus robot up there changing GPUs in the future. Right? But there are a few bottlenecks to it, and like questions, how are they going to do this? They do seem to have the cooling problem down. They have these giant radiators that are going to be cooling the chips, and that seems to be efficient and working. StarCloud has proven that. They've got one up there already, cooling GPUs. And so, yeah, I think they're talking about 40% of data centers being in space by like 2030 something. That's crazy.
I love it. I love it. I love breaking the physical rules of the terrestrial rules we have to follow here. I'm going to open it up for questions in a moment here, Robert. I'll get to Heather. I'm sure that she or someone from the audience might want to ask a question to you with all the insights you've got. But I want to ask the first one, which is, I would love to hear your thoughts on quantum computing. We keep talking about this. I don't think it's everywhere. There's certainly not a replacement for all the computing that we're doing and all the data centers just using quantum for it. But what do you think is the role of quantum? And I want to spot you up with just this one thing that we just saw INQ acquired Skywater Technology last month for $2 billion. That's very small in terms of the magnitude of the numbers compared to the established chip making industry. But that's still a pretty good acquisition. They're doing it because they wanted to bring the in-house capabilities to do some quantum computing manufacturing of those chips. Where do you see this being most interesting with the quantum that's going on?
Well, also back to the Skywater thing.
Yeah.
They're actually keeping it as a foundry. So Skywater bought the Infineon fab that was in Austin.
Right in your backyard there, right? Yeah.
Yeah, right here in my backyard. I was actually there the other day with the executive team and meeting with them. Yep. And but yes, they're going to continue running that fab as a foundry, and then fitting in the quantum technology into that, integrating that quantum business entity into that as well. So they have a secure demand of being able to make chips at a facility, right? I think that's great. It's a win-win for everybody. It's a win. Tom's going to stay as CEO of the company. He's going to continue to run the business, and then they're going to it's going to be really good. I think it's going to be really good. So that's an amazing. What would you call it? A marriage of businesses and trying to merge this make this acquisition happen. But quantum is interesting. I worked on atomic layer deposition, so I like to wrap my mind around something very, 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 very well to understand, to have a true understanding of it. And I still have a hard time with the qubit quantum technology. It is a lot to wrap your mind around. Quantum physics is a lot to wrap your mind around. To really understand where to really understand where it is and where it's at, where it's going. Yeah. Is it going to grow? Absolutely. It's going to be an incredible, part of our evolution of this growth that we're seeing with technology. And is it, do I think it has a long ways to go? Absolutely. It's got a lot of, we're just at the baby phase with quantum technology right now. It's got a very, very long ways to go. So yeah, was this absolutely one of the smartest moves for a fab to do? Absolutely, absolutely, and genius move for IonQ and to get into Skywater at this early stage, because chips are going to be very difficult to get. Samsung, Elon just booked up Samsung, right? Well, Apple's got, TSMC booked up. I was actually talking to somebody at TSMC, one of the executives, and they said, we're booked. We're full. There is no more capacity. We've got a handful of customers, and that's it. We're booked. So where's this coming demand and wave of new stuff that's coming in? Who's going to make it, right? Where is it? And I think a lot of companies like IonQ are worried about that, right? So they pulled that solution and they've solved it. Where are we going? Who's going to make these new chips? Because I think we need to see Intel coming online. They've got a lot of yield problems, right now, and trying to meet that high end yield. And then as they move into EUV technology, doing a lot more of that, they're going to see a lot more challenges as well. So it's going to be very challenging, very difficult for them to do. But I think it's it's achievable. Something they can achieve. They can do it. And so yeah, quantum technology will be interesting for sure. I don't have a lot to say on it because it's there's just not, it doesn't really live in my world a whole lot, as in the space of chips and the chip sectors I work on. But it will be interesting to watch this technology, because it will be it will be another fold, just like artificial intelligence has kind of folded technology. I really believe that quantum technology is going to fold the technology again. It's going to add another fold to it, because it's going to just change everything, right? Just like artificial intelligence is changing everything, quantum technology is just going to absolutely change everything. I don't think it's there yet, and I think that day is still coming, but we'll see when that day comes, and see how much it changes the way that we use this technology. And I think the reason why what are the applications, right? What are the applications that quantum technology is going to affect? Is it just going to be a government thing? Is it going to be is everybody going to have a quantum bit computer in their office? I don't know. I can't really tell you where that technology is going at this time, and it'll be interesting to see where it takes off and how it's utilized. But could it be a solution to a lot of problems? Absolutely, it'll be very interesting. So
it really has been neat to see the progress that they've been making. IonQ specifically. I mean, from being just the technical challenge of building a quantum computer itself, that is not an easy feat at all. And there's different roadmaps you could take for the technology itself. But then, they did that. Then they came public. They raised some money. Then they started getting the contract. She said, government, yeah, the DOD gave them $50 million contract to go out and say, okay, prove it. Let's start putting some of these to work. And now you see them attracting some capital and making acquisitions. You just kind of see everything lining up that, it is, like you said, going to be a pretty exciting and innovative space to keep an eye on.
I always say, follow the money.
Yep, always. As an investor, I can attest and agree.
So follow the money. And so is it something going to be good? Is something going to happen to it? I would say yes. With that kind of investment, absolutely, something's going to happen. But what is going to change in how it's going to change? I just couldn't tell you. I don't know.
Well, I do want to wrap us up. We went a little long, but this was worth it, because this is so good. In fact, Heather, I know we got some live questions from the audience. I don't want to ignore those, but maybe let's make them into a lightning round, Robert. If we can, in the interest of time, kind of get a quick answer to some of these. I have no idea what the questions are, but let's pull Heather in to get some of those live questions.
Oh, no, they were my question.
Oh, yeah. Oh, go ahead. Please go ahead. Yeah.
Oh, okay. When it comes first back to investing in semiconductor fabricators, what are some green flags and red flags to look out for? Because I think the way you're talking about quantum computing is the way most people feel about semiconductor manufacturers,
Yeah.
fabricators.
So you're talking about the fabs themselves, right?
Yep, anyone who's discussing the fabricators on their investing calls, when what should investors be saying is like, that is a word I like, and what are words that you're like, that's time to step back and not
Any
invest in this
red
company.
flags? Yeah, the
Yeah.
intels of the world to tell you. Is there anything you look for, you like, or you don't like?
I mean, absolutely. You got to look at a company's yield, right? What is their yield? Well, that's
And
a
what would
huge
be a good yield?
variety of changes. What is the nanometer level what are they doing? EUV technology, or are they doing 126 nanometer legacy technology from uh, 30 years ago? So like it's variant. You have to figure out what your yield is, what your nanometer size is, what your other fabs are producing around the world, and do that measure. You have to measure that, and I'm sure a quick chat GPT ask
Oh, good
could
idea.
answer a solution to that. But what is the company's yield, and how are they doing with that? Are they expanding? Are they growing? A company that any semiconductor company that's not expanding at this time, I have questions about. That's not doing some type of change. Polar Semiconductor, fairly slow moving company. They're moving into silicon carbide, gallium nitride, the power semiconductor sector, which is great. That's one thing that I always like to talk about. Because in layman terms, I like to remember that we used to carry these bricks with our computers. Like, why don't we carry the bricks anymore? Why is it just this little plug now? Because of power semiconductors. That's why that evolution of technology has changed that. So yeah, it's definitely there's a lot of red flags that can show within a company. But I would say yield is a big one, and also what is their plans for investing and growing? Everybody is planning to grow right now and expand. So there's a lot of I've worked with Rapid, Skywater. Oh gosh, there was another company that's doing MIMS. Oh, she would kill me if I didn't know her name. But another company that's doing MEMS technology. They're all just expansive growth phases right now. Their growth is just incredible, and they're growing faster than they've ever grown in history. So, yeah, anybody that's stagnant, I would say for sure, is a red flag.
And then on the energy side, who are making the small scale nuclear reactors? I know Constellation is making some for IBM, right?
Last Energy. That's the one I was with at College Station.
What was
Last
that again?
Energy is Last Energy.
Last Energy. Okay.
They're building. So they got pretty cool. They actually got fast tracked by the federal government. The federal government fast tracked the federal zoning of the location at Texas A&M for them. So and that's where the bottleneck lies. And that's where I think a lot of people are saying, "Oh, well, it'll never happen. It takes 5 years to federally zone a SMR into a site that's not nuclear, federally zoned." I think the federal government's going to come in and you're going to have it done in 8 months, 7 months. You're going to have that approval. And they just proved that they're doing it at College Station, because they just did College Station in less than 12 months. So yeah. But I think SMRs are going to be very interesting to watch, and to watch that growth. The grid, we absolutely need it. This is the only solution to our enormous bottleneck of power right now. So we have to. And until Elon starts launching data centers into space, there is no solution to it other than that. So
New Scale Power might be another one to keep an eye on too. SMR, that's a publicly traded company. If anyone's interested in looking a little bit more into those as well, I'm a big fan of the space as well. There, Robert. I've got one more question, if it's okay, Heather. If you don't mind, if me get
Nope,
one
that
more
was
in
it.
before
Go
we
for it.
wrap this up. Robert, are we in an AI bubble, or is this an inflection point of more good things to come and demand still red hot?
I think there's always going to be ups and downs.
Yep.
I wouldn't necessarily call it a bubble, because there's always going to be corrections, right? I would say that we're going to continue to see growth. Artificial intelligence is going to continue to change everything. It's such a rapid growth. I am up till 2-3 o'clock in the morning almost every day drinking water out of a fire hose because it's so much information to wrap your head around. It's incredible. Is it a bubble? I don't believe it's a bubble. I don't think it's, but I mean, let me ask you, was the internet bubble a true bubble to you?
No, because it was a foundational technology for the next 2 decades. So
Yeah.
really
So I mean, I
bubble.
kind of see it the same way. Like I don't necessarily see this as a bubble. Is there going to be corrections? Absolutely. But are there going to be some bad investments? Is there going to be some technology that's going to come in? We're going to invest billions of dollars into a technology,
Mhm.
and then a new technology is going to come in, and they're going to be like, oh wow, well, all this is going to be wiped out because this technology is bigger, better, faster. Is that going to happen? Yeah, sure. There's going to be, technological growth is going to be just incredibly fast in the future. So
I'm glad you said that because as an investor too, I keep hearing bubble and AI bubble all the time, but then you see the CapEx budgets, the capital expenditure budgets from Amazon and from
yeah,
OpenAI out there and from Google, and it's just this is not going away anytime soon. It's actually just accelerating. Really exciting space here. Robert Quinn, I have really enjoyed your posts on LinkedIn. I know that you get a lot of attention on the things that you're posting there. Is there anywhere else that we can find you if we wanted to follow along with some of the insights you have about semiconductors?
I'm on X. I'm also on YouTube. Not a lot of followers there, but I'm hitting 70,000 followers on LinkedIn. I reach about 12 million people a year on LinkedIn. So just having talking about the semiconductor industry, where we're going, changes that we're seeing from mergers and acquisitions to technical changes in engineering, to geopolitical events that are happening. I was recently at Texas Semiconductor Summit with Chris Miller, author of Chip Wars. This industry hangs on a thread. It hangs on a thread. That thread is getting heavier and heavier by the day. The supply chain issues are massive. We have to build infrastructure around that. And so like to be able to build a sustainable supply chain for the US. And so that's one of the things I'm constantly talking about and trying to get people to understand the risk that we're currently at with that, and how we can change everything to make it sustainable. So.
Well, Robert Quinn on X.com is at Quinn's Media 1, if you'd like to follow him along there, or also on LinkedIn, where he's consistently posting some great insights about the semiconductor industry. Robert, my friend and fellow Texan, it was a real pleasure to have you here on the 7
It
Investing
is a
Live shows.
pleasure. Thanks so much for having me today. I hope you have a great day.
Absolutely. And for everyone watching, we'll be back again on Wednesday. We're going to be joined by chip stock investor Casey and Nick Rossalillo will be joining the program. We're going to be talking about the dynamic between AMD and NVIDIA, continuing chip week, if we want to call it that, and a lot of stuff that's going on in semiconductors. So stay tuned on Wednesday. That's our next show. We appreciate you being on for this really, really good show here with Robert Quinn. We'll see you again soon. Be safe and be kind to one another. We'll see you again in a couple of days.